Welcome students, welcome to Module 8. In today's module, we'll be covering two-port network. So let us begin our session. In today's session, we'll be looking at different parameters in two-port network theorems. So first of all, we'll start with impedance parameter, followed by admittance and hybrid parameter, and finally the transmission or the ABCD parameters. So we'll be solving some questions related to all these parameters, and in case if you have any doubts, you can ask your doubts in the chat box. So let's start with the first one, that is impedance parameter. So before moving to impedance parameter, I will give a brief introduction about two-port networks. So in case of a two-port network, here we are saying that we have a parameter, any parameter which is having two ports, that is the first port generally called the input port, having a voltage V1 and a current I1, and similarly in case of the two-port networks, it can be the other port, we can call it as the output port, where we are getting a voltage V2 and the current here is I2. So again, in general network port networks, our system can have n number of ports, but in this session we are mainly considering about two-port networks. Okay, so let us begin. And one more thing here. So here we are saying that this network has to be a linear network. So the meaning of linear network here is that it should obey the function should obey the transfer function should obey the linearity property. That is, the linearity property is, so linearity property of a function is given that, suppose if there is a function f of x, then for example, if we give an input x1 and if we give another input x2, then the sum of f of x1 plus f of x2 should be equal to the sum x1 plus x2. So this basically gives us the linearity property. Okay, so let us now, without wasting any time, move to solving some questions related to these parameters. So the first parameter here is the Z parameter, also known as the impedance parameter. So for we have to calculate. So in the first question, we have to calculate the Z parameters for the given circuit. So let us first of all write all the four impedance parameters. These are Z11, Z12, Z21 and Z22. So these are the impedance parameters. So Z11 is V1 by I1, and given that we have I2 is 0. Similarly, Z12 is V1 by I2 given I1 here is 0, and Z21 is V2 by I1 given I2 equals to 0, and Z22 is V2 by I2 given I1 is equals to 0. So we'll one by one calculate all these values. So let us start with calculating Z11. So Z11 is V1 by I1 given that we have there is no current at the net port 2, that is, if we are calling this as port 1 and port 2, so this is an open circuit case here, so no current will flow through the 30 ohm resistor. So in this case, simply we can write Z11 is equal to V1. So here we are attaching a source V1 and there is a current I1. So we can say that we can either write I1 in terms of V1 or V1 in terms of I1. So let us write V1, the voltage across this network. So since there is no current flowing through this network, all the current I1 will flow through the 20 ohm resistor followed by the 40 ohm resistor. So V1 will be nothing but sum of 40 plus 20 ohm and multiplied by the current, total current divided by I1. So this comes out to be 60. So Z11 is 60 ohms. Okay, now we'll calculate Z21. So Z21 is V2 by I1 given I2 is equal to 0. So here we have to take I2 equals to 0. So I2 equals to 0, again the same case. So the voltage drop across the 40 ohm resistor will be V2. So V2 we can write as 40. So here we have to consider the signs also. So since the direction of flow current is like this, there is plus minus sign, and we have to calculate this V2 value. So the signs are same, so there will be no change in sign. So V2 will be 40 multiplied by I1 divided by I1. So that is 40 ohms. Similarly, we have to calculate Z12. So in this case, there is slight change. So in case of Z12, that is V1 by I2, we have to open circuit the port 1, that is I1 is 0. So let us remove this voltage from here, and in this case now we have a voltage connected here, V2 plus minus, and there is no flow of current from the input side, that is I1 is equal to 0. So the voltage across V1 will be the voltage at the 40 ohm resistor, since no current is flowing. So it is 40 times I2. So this is I2. I2 is the current flowing divided by I2. So this comes out to be 40 ohm. And finally Z22, that is V2 by I2 at I1 equals to 0. So V2 will be the total potential drop here. So 40 plus 30 times I2 divided by I2, it is 70 ohms. So these are the so you can write it in a matrix form. So Z11 is 60, Z12 is 40, and Z21 is also 40, and this is 70. So this is the Z matrix, Z parameters. Okay, so let us move to the second problem. So this problem is also related to a impedance matrix. All the parameters here are given, all the Z parameters are given, and we have to calculate I1 and I2. So we can write the equations. V1 is equal to Z11 I1 plus Z12 I2, and V2 is equal to Z21 I1 plus Z22 I2. So here V1 and V2 values are given. So V1 is given 100 angle 0, and V2. So if we see the direction of current, so the current is flowing in this way. So this is plus and this is minus. So that is why the direction of V2 will be negative of 10 times I2. Okay, hope this is clear, because the convention V2 is plus minus, but the voltage drop of the resistor is opposite. That is why there is a negative sign. So just substituting all the values in equations, in these two equations. So V1 is 100, Z11 is 40 I1 plus Z12 is J20 I2, and V2 we can write minus 10 I2 is equal to Z21. Z21 is J30 I1 plus Z22 is 50 I2. So we can also write this equation as 60 I2 is equal to minus J30 I1, or I2 is equal to minus J by 2 I1. Okay, so I2 will get minus J by 2. So let us substitute this value. So substitute the value for I2 in equation number 1. So 100 is equal to, so I am writing this equation now, this equation. So 100 is equal to 40 I1 plus J20, and now I2 is minus J by 2 I1. So 100 is equal to 40 I1 plus J multiplied by J is minus 1. So this will become 10 I1. So 50 I1 is equal to 100. So I1 will be getting 2. And similarly I2 from here will be minus J. So 2 and I1 will get cancelled. So these are the values for I1 and I2. That is 2 amperes and minus J amperes. So minus J is 1 angle minus 90 amperes. So this is I2. So now let us move to the second parameter, that is the Y parameters. So in case of Y parameters, we write current in terms of voltage. So it is completely reciprocal of the impedance parameter that we earlier saw. So the equations here are for I1. So I1 will be equal to Y11 V1 plus Y12 V2. And similarly I2 will be Y21 V1 plus Y22 V2. So in this case, for V2 equals to 0, so if we put V2 is equal to 0, that is we are short circuiting the output terminals here. So in case of V2 equals to 0, we can get Y11 is equal to I1 by V1. And also if we see from this equation, that is if we put V2 equals to 0, so let me write that this is V2 equals to 0. So this is V2 equals to 0, and from the second equation, if we put V2 equals to 0, we will get Y21 is equal to I2 by V1 at V2 equals to 0. And similarly, if we put V1 equals to 0 here, V1 is 0, so from here we will get Y12. So Y12 will become I1 by V2 given V1 equal to 0. And similarly, if we put V1 equals to 0 here in the second equation, that is V1 equals to 0, so this portion will get cancelled out, so we'll get Y22 is equal to I2 by V2 given V1 equal to 0. So these are the 4 parameters that will mainly get these parameters: Y12, Y11, Y21, and finally Y22. So let us, on the basis of these admittance parameters, will calculate for the circuit. So let us first of all calculate Y11. So in case of Y11, we have to short circuit V2. So now there is no potential drop across the output terminal. We have short circuited. So and connect voltage source V1, and current here is I1. So we have to find V1 by we have to find I1 by V1. So let us calculate. So the flow of current, there no current will flow through the 8 ohm resistor because current flows through the least resistive path. The proportionally it will flow to the least resistive path, and since this is a short circuited wire, so there will be no current flow. So the circuit here is parallel connection of 4 ohms and 2 ohm. So I1 will be, we can write I1 as V by V1 by the equivalent value, that is 4 ohm parallel to 2 ohm and divided by 1 by V1. So this will become 1 upon 4 into 2, and in the numerator side we'll have 4 plus 2, that is 6 by 8, that is 3 by 4 or 0.75 Siemens. So this was Y11. Similarly, we'll calculate Y21. So Y21 is I2 by V1. So I2 is, this current is I2. So we have to use the current division rule here. So the current I1, some current will move to this portion, and other current, component of current, will move to the 2 ohm resistor. So the current passing through the 2 ohm resistor will be opposite of that of I2. So that is why there will be a negative sign here. And the current passing will be 4, that is the other resistor, divided by the sum of resistors, that is 6 times I1. This will be the value of I2, and divided by V1. So I1 by V1 we have already calculated, that is 0.75 Siemens or 3 by 4. So minus 4 by 6 into I1 by V1 is 3 by 4. So this comes out to be minus 1 by 2, that is minus 0.5 Siemens. So these two parameters calculated, and let us finally calculate Y12. So Y12, in this case now we have to short circuit the input part. So we will short circuit this part, that is V1 is now 0, and we have to calculate I1 by V2. So V2 is a source connected here, V2, this is I2, and the current here, this one is I1. So let us first of all calculate I1. So again here there will be no current flowing through the 4 ohm resistor. So I2 will bifurcate into this portion and this portion. So the current through the 2 ohm resistor in terms of I2 will be opposite of I1. So again a minus sign here. So minus. Now again using the current division rule, 8 by I2 divided by 10 and whole divided by 1 upon V2. Okay, so this will be minus 8 by 10 I2 by V2. So I2 by V2 we haven't still calculated. So let's us first of all calculate Y22 parameter. So that will be a much easier way to calculate. Other way you can also calculate. So let us first of all calculate Y22 parameter here. So I2 by V2. So let us write I2 as it is, and now let us calculate the total potential in terms of I2. So the potential in terms of I2, since this is a short circuit, so 2 ohm and 8 ohm resistors are in parallel. So let us say 2 ohms and 8 ohms resistors are parallel, so the total amount of current that I will draw will be V2 times equivalent resistance, that is 2 into 8 into 10, that is in the parallel combination, and divided by V2. So this is V2 cancelled, this will become 5, so 5 by 8 Siemens. So this now let us substitute that value here, minus 8 by 10 into 5 by 8. So 8 gone, and 5 and 2, so this again 0.5s. So these are the parameters. So 5 by 8 is 0.625. So therefore we have all the parameters. So I will summarize all the parameters in a matrix form. So So this is our y matrix. Y11 is 0.75 Siemens, Y12 is minus 0.5 Siemens, Y21 is again minus 0.5 Siemens, and Y22 is 0.625 Siemens. So these are the Y parameters. So let us move to solving a problem related to Y parameter. So here we are given with a problem with the Y parameter. So let us follow the same way. First of all, you have to calculate Y11 since all the parameters have to be calculated. So Y1 is I1 by V1, given that we are short circuited, so V2 is 0. So V2 is 0 means that we have short circuited this part. These are V2 and I2 portions, so this is I2 and this is I1, and we have calculated source V1 here. I small I is nothing but I1. Okay, so let us consider this as a node and this as the ground, and let us call this as V. So from nodal analysis we can write for this node the current flowing. So we'll take all the direction of current away from the node. So minus I, since the direction of current is inwards, minus I plus V by 2, that is this current, plus 2I, that is the current through the dependent source, and finally through the 4 ohm source the current will be V by 4 is equal to 0. So I plus 3 by 4 V is equal to 0. So this is our first equation. And also we know that V1 minus V by 8 is I. So let us substitute I here. V1 minus V by 8. So it is better to substitute small v because v will not come in our in our y parameters. So let us find v here. So v is 8I. So v is minus 8I. So v is equal to minus 8I plus v1. No. So 8I, yeah, it was correct. So this will go 8I and finally minus V1, and on the negative side minus 8I plus V. Yeah, so this is correct. So V is this one. So let us put the value of V in this equation. So I plus 3 by 4. In case of V, we are substituting with minus 8I plus V1 is equal to 0. So also I is I1. So I1 minus 6 I1 plus 3 by 4 V1 is equal to 0. So 5 I1 is equal to 3 by 4 V1. So I1 by V1 is equal to 3 by 20. 3 by 20. So 3 by 20. 3 by 20. So dividing by 2 is 1.5 and as 0.15 Siemens. So 0.15 Siemens will get I1 by V1. So similarly we have to calculate all the other parameters. So the second task will be to calculate Y21. Okay, so let us calculate y21 then. So y21 will be I2 by V1 given V2 is equal to 0. Same case, but in here we will have to calculate I2. So we can write I2 here. So here I2, if we look at this node, so I2, if we take all the currents for that node, so I2, all the currents are coming inward, so let us consider that sign, and plus V by 4 is equal to 0. Okay, and we have calculated V earlier. V was calculated, so V was calculated to be V1 minus 8i. This we had already calculated V. So if we put this I2 plus 2i1 plus V1 by 4 minus 2i1 equal to 0. Okay. So now from here we have to calculate I2 by V1. So I2 is there, we need a relation between I1 and I2 to solve this problem. So let us see if we can find a relation for. So let us first of all simplify this. So I2, okay, so no problem. I1, 2i1 is getting cancelled here. So that will be I2 plus V1 by 4 equal to 0. So I2 by V1 will become minus 1 by 4. So this will be minus 1 by 4 Siemens. Okay, so the first two parameters are calculated. Now the problem changes a little bit. So now we have to short circuit the input terminals and apply a potential at the right side. So this will become I2 and I is I1, I is I1. So for this case now we have to solve the problem. So we can have to again calculate for the node, or we can also find the currents directly. So it's better to calculate y12 first. So let us calculate y12. So y12 is I1 by V2. Sorry, I1 by V2 given V1 is 0. So, and the other thing will be to calculate y22, that is I2 by V2. So let us calculate first of all y22. So V2 here, so we know from the node we can write at the node minus I1 plus twice I1 plus V, so this node is at a V voltage, by 2 plus V minus V2 by 4 is equal to 0. And also we know that since this terminal is at ground, so I1 is V by 8. It's minus V by 8 because the direction of current here is inwards. I'll just substitute these two values here. So we'll get, so I'll just make some space. So y11 is 0.15s and y21 is minus 0.25s. Okay, so substituting I1 here, so it is V by 8 plus, so minus I1 plus 2I1, that is plus I1 is minus V by 8 plus V by 2 plus V minus V2 by 4 is equal to 0. So now we can get here V. So V will be minus 1 by 8 plus 1 by 2 plus 1 by 4 is equal to V2 by 4. So taking the LCM, 8 minus 2 plus 4 plus 2 minus 2 plus 2. Sorry for that. Minus 1 plus 4 plus 2 is equal to V2 by 4. So minus 1 and 5 by 8. So V into 5 by 8 is equal to V2 by 4, 4, 2. So we'll get V is equal to 2 by 5 V2. Okay, so we now get the value of V. So now we have to calculate I2. So I2 in terms of V2, because I2 by V2 which will get cancelled out. So since there are only two sources of current, two is I1 and I2 are coming here, so this will only pass through this resistor. So V minus V2 by 4, that is this current, will be equal to negative of, since both are coming together, so that when negative sign, those are against direction. So twice I1 plus I2. So V we know 2 by 5 V2 minus V2 by 4 is equal to minus 2 I1 plus I2. Okay, so this will become minus 3 by 20 V2 is equal to minus twice I1 plus I2. Again we have to find I1 in terms of V2, so I1 we have already calculated, minus V by 8. So this was minus 1 by 20 V2. So I am substituting V2 from the equation in the box. So V is 2 by 5. So 2 by 5, 2 and 8 we will cancel out 2 by 4, and 4 times 5 is 20. So this is gone lengthy, but not to worry. So I1 is minus 1 by 2 V2. So just substituting that value, this value. So we'll substitute this value of I1 to finally arrive to our relation. So minus 3 by 20 V2 is equal to minus 2 times minus 1 by 20 V2 plus I2. So minus gone and 10. So let us take this side, V2 minus 3 by 20 and minus 1 by 10 is equal to I2. So I2 by V2 is equal to minus 5 by 20, that is minus 1 by 4, that is 0.25. So Y22 will get minus 0.25 I2 by V2. Okay, and finally we have to calculate y12 by y12. So I1 we know minus 1 by 20. So let us substitute I1 here. I1 is minus 1 by 20 V2 divided by V2, that is minus 1 by 20. So y12 will become minus 1 by 20, that is minus 0.05 seconds. So these are the values. So let us move to the next problem. So the next problem here is we have to calculate the H parameter for the below circuit. So let us calculate H11, H21, H12 and H22. So for case of H11, this is equal to V1 by I1 and the given thing is V2 equal to 0. H21 is I2 by I1. So these are mixed parameters. First one is impedance, second one is dimensionless, that is V2 equals to 0. And the third one here is again dimensionless, V1 by V2, but given here is I1 is equal to 0, and finally we have I2 by V2, that is admittance, given I1 equal to 0. So V1 by I1 given V2 equal to 0. So let us start this V1 by I1. So we have calculated. We have already solved this kind of problem, V1 and I1. This is similar to the Z parameters. So in this case the 6 ohm and 3 ohm resistors are in parallel and then series with the 2 ohm resistor. So let us write that this is equal to 2 plus 3 parallel to 6. So 3 into 6 by 9, 2 plus 3 into 6 by 9. So 3 and 2, so 2 plus 2, 4 ohms. 4 ohms is the first parameter. Second one is I2 by I1. So this is I1, this is I2. So let us take I1 as it is, and now we have to use the current division rule. So there is negative sign because the flow direction is opposite. So minus 6 by 9 sum of 6 and 3 times I1. So this is minus 2 by 3. This is dimensionless. On the third one, case of third one, V1 by V2, we have to not short, you have to open the input ports and connect the supply here, the right side. Direction of flow is I2, I1 is 0, there is some potential V1. So first of all we have to calculate V1 by V2. So the voltage V1 will be same as the voltage across the 6 ohm resistor. So using the voltage division rule, 6 by 9 times V2 divided by 1 by V2, that is 6 by 9, that is again 2 by 3. This is again dimensionless. And the third one, sorry, the fourth one, I2 by V2. So I2 by V2, since this is open circuit, no current will flow, so this will be simply the sum 3 and 6, that is 9. But it is opposite, signs are opposite. Sorry, this is not impedance but admittance, so that is why we have to write it as 1 upon V2 by I2, and then V2 by I2 is 9, so 1 by 9. This is unit always Siemens. these are some 6 and 3 ohms. So let us move. So these are the transmission parameters. So we have to calculate the transmission parameter. That are the ABCD parameters. So the transmission parameter for the below circuits are given. That are the ABCD parameters. The output port is connected to a variable load for maximum power transfer. Find RL and the maximum power transfer. So these two values we have to calculate. So as per the network theorem, we have already discussed that the voltage for maximum power will be the Thevenin's voltage across the output. So here in case the voltage here VTH and the resistance at the felt by these two nodes are called the RTH. So if we know VTH and RTH, we can calculate the maximum power. So first of all, let us calculate the Thevenin's resistance for the given network. So while calculating the Thevenin's resistance, the rule is to short circuit any voltage source and open circuit any current source. So we'll short circuit the voltage source here. So we have a 10 ohm resistor, then the ABCD parameters. This is the 10 ohm resistor, and we'll short circuit this portion, and we have to calculate the Thevenin's resistance across this point called RTH. And the direction of current here, so this will be I1, and since this is a T power transfer, the transmission parameter, so that is where the direction will be minus I2. So this we generally use because in transmission lines we deal in segments. So if suppose we have a segment here and we take the direction I2, so now it will be easier for us to join this with any other network. So this will be I1, so let us call this I3, and this as minus I4. So now we can easily say that minus I2 is equal to I3. So that is why the sign here is taken negative, which is a distinct feature from all other parameters. So that is why this is the main reason for taking the negative sign minus I2. Anyways, we'll calculate the Thevenin's resistance for the given node. So this is I1 and voltage here is plus minus V1. So this is plus minus V1, and this is I2, and voltage will be same, plus minus V2. So first of all, let us find a relation between I1 and V1 here. So the direction of current flow is like this. So this is plus and this is minus. Again, this is opposite of as compared to this. So V1 by I1 is 10 ohms. A negative sign will be there because the resistor is a load, not a supply. Okay, so V1 by I1 we know is minus 10. So let us write this I1 as minus V1 by 10. Now let us write all the ABCD parameter equations. So first of all, we'll write V1 is equal to A times. So I'll just directly write this. A here, these are the ABCD parameters A, B, C, D. So A times, that is 4 times V2 minus 20 times I2, V2 I2. And then I1 is equal to 0.1. So we'll write for I1. So let us first of all simplify this term. So we'll directly write the equation that we have to solve. So from here we can write V1 in terms of I1. So that will be minus 10 I1 is equal to 4 V2 minus 20 I2. So I1 will be minus 0.4 V2 and plus 2 I2. This is our first equation. So in the second part we can write that minus of 0.4 V2 plus twice I2 is, that is I1. I1 is in I1 will write in terms of the ABCD parameters. So I1 is C times, that is 0.1 times V2 and minus, so our minus sign has to be there, I into I2. So we have I2 V2, I2 V2, yeah. So RTH is V2 by I2. So we can now simplify this and calculate RTH. So let us do this. So taking V2 together, so 0.5 V2 is equal to 4 I2. So these 2 I2, 2 I2, 4 I2. So V2 by I2 is equal to 4 by 0.5, that is 8 ohms. So this is RTH. RTH comes out to be 8 ohms. So first step of the problem, we have obtained RTH. Let us write RTH is equal to 8 ohm. Now the second task is to calculate. Second task is to calculate VTH. So in case of VTH, you have to find the voltage here at these nodes. There is no resistor, just open circuit it and find the voltage. So let us find VTH. So from the ABCD parameters, this term here means that there is no flow of current. I2 is 0. So this minus I2 is 0. Since this is open circuit, there is no flow of current. So V1 by V2 will be A. So A is given as 4. So V1 is equal to 4 V2. And the second thing here is, we already know from the left side that I1, this current I1, this point is V1. So I1 is 50 minus V1 by 10. Okay. Still we haven't come closer to calculating V2, but we have already found a relation between I1 and V1. So next step, we can use other parameters here. So let us simplify this. 10 I1 is equal to 50 minus, sorry for that, 50 minus V. Okay, V1 is so V1 is given in terms of 4 V2. So V1 is given as 4 V2. Also from the C parameters we can get I1 by C is I1 by V2. Yeah, C is I1 by V2 given that I2 is 0. So from here we can get V2 is equal to I1 by C. C is 0.1. So now replacing V2 here, so V1 is equal to 4 into V2, that is 4 by 0.1. I1, that is 40 I1. V1 is equal to 40 I1. We can put it here and solve the problem. So 10 I1 is equal to 50 minus 40 I1. So from here we can get I1. So 40 plus 10 is 50. 50 I1 is equal to 50. I1 is equal to 1 amperes. Now we have I1, we can calculate V1, and from V1 we can calculate V2, or we have already derived the relation V1 is equal to 40 I1. We already got from the earlier relation. So from here we can calculate V1 is equal to 40 volt and V2 is V1 by 4. So 40 by 4 is 10 volts. So V2 is 10 volt and V2 is our Thevenin's voltage VTH. So this is VTH. This is the VTH. So now we have VTH 10 volts. So we have already know the formula for maximum power transfer theorem. So the Pmax, that is power for maximum power transfer theorem, is VTH by twice RTH squared times RTH, or RTH is the load resistance R. So VTH is 10 by 2 into 8 squared times 8. So use your calculator to calculate. So 10 divided by 2, 10 divided by 60 squared times 8, 3.125. 3.125 watt. So Pmax will be 3.125. And how much load we have to connect? We have to connect RL as 8 ohms to get the maximum power from the network. So we have seen the to summarize for today's class, we saw the impedance parameters, that is Z parameter. We also covered the admittance parameters, that is also known as the Y parameter. Then we solved few problems related to this Z and Y parameters. The third thing that we discussed was hybrid parameters, so the H parameter, and finally we saw the T parameters, also known as the ABCD parameters or transmission parameters. Okay, so If you have any doubts related to this class, you can write your doubts in the chat or comment box, and I will try to answer all of your questions. I'll wait for 2 minutes. If you have any doubts, you can ask. Okay, so in case you don't have any doubts, we can end our session today here. Okay, we'll again meet next week on Tuesday with module 9. So I will end the session now. Thank you.